All right, welcome. Have you ever just sat there and wondered what's really going on inside an AI's head when it's learning? Well, today we're going to pry open that black box. We are going to look at exactly how a smart traffic light goes from being, just a dumb machine to a truly intelligent system that can actually tackle real-world traffic. Let's get right into it. So, this is really the big question we're trying to answer today. I mean, we've all been there, right? Stuck in a hopeless traffic jam, just wishing the light would, get it. Well, this is the tech that's designed to do exactly that. But how? How does it learn to make these smart calls all on its own, without a human programmer sitting there and spelling out every single rule? To really get our heads around this, first we need to understand why the old ways just weren't going to cut it. We are moving away from these really rigid, rule-based systems and into a whole new world where machines can actually learn from experience. Okay, now check out this contrast, because this is really at the heart of it. On the left, you've got the old method, something called Q-learning. The best way to think about it is like a giant cheat sheet or a Q table. For every single possible traffic scenario, you'd have an answer written down. But, real-world traffic has a practically infinite number of situations. You could never, ever build a cheat sheet that big. So on the right, we throw out the cheat sheet, and we replace it with a flexible brain, a neural network. This thing doesn't just look up answers, it actually learns how to figure them out for itself. So, let's get to the good stuff. What does this digital brain actually look like under the hood? We're going to walk through its architecture piece by piece and see exactly how it thinks. At its core, it's actually a pretty simple three-step flow. First, the brain has to see the world around it. That's the input layer. Then it has to think about what it's seeing, and that happens in the hidden layers. And finally, it has to act on that thinking, which is the job of the output layer. See, think, act. Let's break each of those down. First up, the input. This is how the AI actually sees the intersection. But here's the clever part. It doesn't just get a flood of raw, noisy data from the sensors. No, instead, it gets a nice, clean, filtered snapshot of what's happening. A really cool tool called a Kalman filter processes all the data first, giving the AI a clear, simple picture of things like how many cars are waiting and how fast they're moving. And you need that clean input, because you can't learn well from messy information. Okay, so that clean data then hits the hidden layers. And this right here is where the magic happens. This is the deep thinking part. For our traffic light, there are two of these layers, each with 64 artificial neurons. And their entire job is to find the complicated, non-obvious patterns in the data. They're figuring out how, say, a long queue of cars on one street might affect the speed of cars on the cross street. This ability to find these deep, hidden relationships is exactly why we call it a deep network. And finally, we get to the output. After all that thinking, the brain has to make a decision. So what it does is it produces a score, they call it a Q value, for every single action it could take. Things like keep the north-south light green, or switch over to the east-west. The action that gets the highest score, well, that's the one the AI thinks is the absolute best move to make in that exact moment. Okay, so we've seen the brain's anatomy. Now let's follow a single decision as it makes its way through the system. We're going to watch the AI make one choice in one single moment in time. It all starts right here. The AI observes. It takes in that clean, filtered snapshot of the intersection. This is the current state of the world. Right, so based on that state, the network fires up, crunches the numbers, and spits out those Q value scores for every possible action. Then it just picks the winner, the action with the highest score, because that's what it predicts will lead to the best outcome. Now, after it takes an action, the AI gets feedback. The environment basically gives it a report card, a reward. Did traffic start flowing better? Great, that's a positive reward. Did it accidentally cause a massive gridlock? Uh-oh, that's a negative reward. This simple feedback loop is the absolute foundation of how it learns anything. And that reward signal, well, that brings us to the most important part of this whole thing. See, it's not enough to just act. The AI has to learn from what happened because of its actions. This is how it actually gets smarter over time. So how does it remember all this? With a brilliant technique called experience replay. Just think of it like a memory bank. Every single time the AI does something, sees a state, takes an action, gets a reward, and sees the next state, it stores that whole sequence as a single memory. Now, to learn, it doesn't just look at the last thing that happened. It reaches into this bank, pulls out a random handful of memories, and replays them. This is so smart because it stops the AI from getting too focused on, say, one weird traffic jam that just happened and helps it learn from its entire history. So, how does it learn from those memories? It's all about measuring surprise. This slide breaks it down perfectly. Let's say before it acted, the AI predicted its move was worth a score of like 6.2. But after it saw the actual reward it got, the real result was calculated to be way higher, 14.39. That huge gap, that difference between what it expected and what actually happened, that is the surprise. In machine learning, they call it loss. And it's basically a big red flag that tells the AI, hey, your guess was way off. Time to update your thinking. And here's where that surprise signal gets put to work. It doesn't just vanish, it actually travels backward through the entire neural network, from the output all the way back to the input. And as it goes, it makes a tiny little adjustment to every single connection it passes. If the prediction was too low, it nudges the connections to be a bit stronger. If it was too high, it weakens them a bit. This whole process is called backpropagation, and it is literally how the brain rewires itself to make a better guess next time. Now, as you can probably imagine, a system that's constantly rewiring itself based on every little surprise, well, it could get really chaotic really fast. So, the engineers who built this put in a few very clever tricks to keep the whole learning process stable and on track. And probably the most important trick is something that's basically a tale of two brains. Instead of just one brain, the AI actually uses two of them. You've got the main network, which is the student. It's learning aggressively, updating with every single experience. But then you have a target network, which is like the teacher. It's an older, more stable copy of the main one that only gets updated every once in a while. This is so important because it gives the student brain a stable goal to aim for. Without it, the AI would be chasing a target that's moving every second, and the whole thing would just spiral out of control. So when you zoom out and look at the whole picture, it all rests on these three pillars of stability. You've got experience replay, making sure the AI learns from a wide range of unbiased memories. You've got the target network, giving it a stable goal to learn towards. And you have the Kalman filter, making sure the AI is learning from clean, reliable data to begin with. Altogether, they create this really robust, effective environment for learning. And this quote from the original research just sums it all up perfectly. The filter, the deep Q network, the memory replay, the two brains, they're not just a random collection of tricks. They all lock together to form a single adaptive system that can intelligently control a super complex real-world problem, like traffic. So there you have it, a peek inside the AI brain. It's this incredible dance of seeing, thinking, acting, and then learning from the past. And it really leaves you with a pretty massive question, doesn't it? If this kind of AI can learn to untangle a city's traffic, what's the next chaotic system it's going to master? Think about logistics or financial markets or even our climate. What's next? Thanks for joining me on this one.